Slide. Should be. Yeah, it's live now. So hello everyone. Mushtaq. I work for Thoughtworks office. So I really like this conference room, like very cozy. How many of you are from Ideas? And I'm assuming that all of you are developers, right? Okay, how many are developers? Oh, majority. And how many of you have seen this already either video or on today's class symposium? None, right? Okay, cool. So this is a repeat, right? This is a repeat of what I did for today's class symposium. Let me get started. So this is about how much time do we have? I mean, I can go on. So I presented this in 45 minutes, but if you
I think we have more than
that. So this is about the reactive jargons. I mean, have you heard of reactive? The word reactive, and what does it mean? Who's marketing that? What are the things around it? Are you aware? Who's aware? Okay, yeah. So TypeScript is heavily marketing reactive thing, right? There's a reactive manifesto, there's a reactive streams, and it's a nice word which captures the intention of behind the design principles that some of these systems have. We have heard of Node.js, very common, right? Node.js we all know. Akka, have you heard of Akka? An actor systems. I think these are the systems which allow you to write a very scalable application. I mean, you very resource efficient, just a single machine, single thread to really scale for an IO-bound operation, which is what many web applications are. And the principle, I mean, Node.js they call it callback based. Akka is message passing, and some event driven and whatnot. So the gist behind that is what Reactive Manifesto trying to capture is that all the applications are reactive. They react to different things, load and scalability and stuff like that. So we'll not go there, but technically there are a lot of things that you have to work with when you programming a reactive system. I have been working with Play. Have you heard of Play? Play is I have been working on Play for like 2 years now. And Play is built around reactive systems. Current Play, the crux of Play is around Netty. Netty is a Java system. How many of you are from Java background? Okay. So Netty is a Java. What Node is for JavaScript, Netty is for Java. It's a very robust, very old system. And Play is currently architected around the Netty. Eventually, it's going to move to Akka and Reactive Stream in the later versions, but currently it is. But Play doesn't expose the Netty API because Netty API, like Node.js, is callback based. So it gives you a better abstraction according to me and according to many who like that abstraction. And that is called as futures and promises. Again, very well known in the Node.js community. Not many people use it, but that is the only model basically to work with in Play. So what I'm going to set a context that okay, what kind of a web application that we are building and how these reactive abstractions of features and promises and others, right, they help us, why they are most mandatory. So I mean, this is very simple. Like on the first part here, right, this thing is a front-end server, and these are the back-end services. You must have done similar ones. And a single request from a user to get one page translates into many requests on the backend. This number could be ridiculous. This is like 4 or 5 in some cases, or it could be 50 in our case. Right? We are building a CMS-like system, but we want it to be so configurable that each part of the web page is modular, right? And is configured separately. That's what it's called separately. So we have like 50, sometimes 100, up to 100 calls to the backend systems. And your services in turn can go to multiple backend storage to storage otherwise. And now this is the problem. We all know that concurrency is handled well with the traditional Java applications that app servers that we use. So for Java, what is the commonest app server that you deploy to? Can you middle name? Tomcat, for example. Tomcat is like a thread-bound app server. But it scales very well because the requests can be, you can say that every request takes one thread, and then if you have good amount of memory, you can say that deploy to 1,000 threads, and that is very much feasible. So request level parallelism or concurrency is handled and scales very well even with the threads if you have enough memory. Now what we are talking here of this over here, right, which is intra request or within a request. Once you get a request, you have to go to multiple places and now there is no direct support in any of the app servers that you're using. No direct support basically to this kind of a conflict. In fact, this is restricted, it's prevented. You're discouraged to spawn threads within the request, right? You delegate that to the framework, and framework does it for request but not within the request. I think that motivates the problem there, right? So what we are going to do is deal with this problem and see that how these systems can help you do that. To make it more concrete, what I'm going to do is for example, for my demo, this will help if we say that the request is coming for obtaining squares of a sequence. Let's say that okay, I have a sequence of integers and t squared. And then for whatever odd reason, each number I will make a separate service call. Just for the thing. So my backend service knows how to square a single number. And I have to do those many calls, right? Assume that the sequence could be big, like 100, 200, and then we have to do it efficiently and without being efficient, not in terms of response time, but also the resource consumption, like maybe. So from this point, right, I'll start with the demo. So what we are going to do is, let me see. So I have some tests right here, which is like which is not popular. So I'm going to do it with you guys. So what we are doing here is, I'm saying that square a number. I'm going to implement first a blocking where you square a number, and I will say that okay, this square should be 100 if the number is 10. If I run this, it will not work because I don't have implementation for blocking. Okay, so I'm going to implement that, but I need some helpers there. So first of all, underlying mechanism on my backend server is a square function, and blocking is just a delegate to that with some logging so that you understand how it's actually working. So what blocking is doing is it's saying that first before you begin you make a log, and then you actually delay the operation by a random number less than 5,000 milliseconds. So less than 5 seconds, some random delay, and then compute the result. And after your result is done, log so that we know when the cause happened, and then return the result. Right? So if I now do this, I should be able to run this test. And let's try to understand how the logging statements are happening. Okay, so the operation begins, and then some random 5 seconds, and then it ends, and then the call returns. So you all find it familiar that there is nothing surprising. The call has to return after the operation is complete. Right? I mean, because it's a normal square function which the blocking, the delay is representing some IO delay, right? And this is not very surprising. Now let's try to do this in a batch. So all these concerns become interesting when you are working with a batch. That's the example that you motivated earlier. Right? So in a batch, it's going to be like this. What I'm going to do is I'm going to call a blocking function on squares object now, which is capable of working with a sequence. I think I did not ask you one question. How many of you are familiar with Scala? A little bit. I mean, you can see the code earlier.
We had some sessions earlier.
So this particular function is able to compute for a bulk. So this is a batch or a bulk operation on integers. And what will it do in the end? It will delegate to the single operation that we just looked at. Now, how will the bulk look like? So the signature of bulk operation will be okay. I get numbers and I return numbers. A sequence of it. And the implementation will be very trivial. So if you know, I mean, there is some I'm sure you know what a map function from Ruby or other languages, right? So it will take the numbers and it will map it, and while mapping it will delegate to the blocking single square function, and then you get a bunch of squares that you return. What I'm going to do now is test this by running this. Let's see what is the behavior. So what will you expect when I make a blocking call, which is delayed, which is randomly delayed? Sorry, so what will you expect? I'm trying to square 10 numbers, and my calls are blocking. Okay, enlarge this. So yes, it starts with 1 and then finishes 1 and then 2 and then finishes 2, right? So we have possibly only 10 numbers, so it will end. But this gives you an idea that if you're making 10 network calls, right, the response time, not only the efficient resource consumption, but also the response time is going to get affected if this is your architecture. So you have to do something about it. And I'm sure even in Tomcat, you will devise a way to overcome this. And in the end, call returns right in the end. That's not very surprising. You see the results. Now, what we are going to do is let's do this in an async way. And one of the focus of this talk is basically talk about the familiar terminology like async, blocking, non-blocking, streaming, and it's different, but people use these words in a similar way and confuse each other. That's what I feel. So we are going to I'm going to call something async, and you will find out what is happening here. So what I want to do is using this async API, which apparently gives me a future. I want to square. My claim is that this future API doesn't block, so my call will be immediate when I run this, and then the results will come. Of course, I don't have implementation of that, so I have to go here and then how the implementation will look. Well, it's a hack. So what I'm doing is I'm still making use of my blocking, but I'm boxing it inside a future constructor, and of course it will return immediately for the caller. But there is some resource being blocked, some thread being blocked. So that's why I'm not calling this non-blocking. I'm saying that it's just async because this API is async. So whoever calls, it doesn't have to wait, but that doesn't mean that you're not consuming the thread. So that's a distinction I want to bring out. To make this work, because I'm using futures, I need to set up something. So which is the configs? Future takes another parameter here which is not visible to us. So this is called execution context, and I'm just going to create that execution context here. So here it's all right. I come in here. I'll talk about what is an execution context. For this particular operation, even though it's a blocking operation, I'm wrapping it inside a future. Now, future, they should be told that okay, this thread pool to run it out. So I create a thread pool. I use Java API to create a thread pool. That is simple Java concurrent. And Scala has a notion of execution context which all future understand. And one way of creating that is wrapping that thread pool. So I'm saying that okay, I create a thread pool of thread pool basically of the given number, and then create the execution context out of that, and the whole instance of this is a config object, which I'm able to now use. So if I do this, and I import that execution context in scope, then my program has the ability to basically schedule this operation. This is a kind of a scheduling. So let's see what is the effect of this. So we go to a square and let's run this async. So in case, what will happen now?
So it will be blocked, but randomly maybe.
Right, but I'm making just one call, and if you notice, my config object had a thread pool of 4, right? So I'm still all right. So which means that my call returns immediately for the caller, which is my test. That's why the first time is call return, then the operation starts. It could have started earlier, that's not a problem. But it definitely ends after my call returns, right? Because there is a delay there. Okay? And this is not very surprising. So even though I blocked, I consumed one thread, I can claim that my API is async, and I can say, okay, this is how I will do it, right? But this is cheating, and you will know very soon that this will not scale. So, for example, instead of having a single operation, let's do a batch operation. So I will do a batch operation. What is this batch operation doing? Similar to the blocking, giving a range of integers and get a future. But now this future contains a sequence. This is not a future containing a single value. It's a future containing a sequence. And I said that once this is complete, so I need to put a callback. So once this is complete, print the value, right? And I need to await before I exit my test. I need to await, saying that the future has to be written in test, not in application. So to do this, I must implement this. And this is the signature. I take a set of numbers and I give you future of numbers which are square. To do this, I create. I just use map again, but then I use something else, sequence also. Why? So if I just use map on numbers, if each call is related to async, which is giving you a future of integer, I will get the sequence of futures, right? So that's why the name futures. I'm getting many futures. I can't deal with many futures, right? I have to. I have a deterministic. If I want my program to be deterministic, for example, if I want to compute the sum of all integers, I mean, I can't deal with futures. I have to deal with future of multiple items, which is sequence, for example. Right? And the library provides you a way to just change the shape. So the future which is inside comes out, and the sequence which is outside goes in. It's a magical operation, but the library allows gives you a method to do that. That's of sequence, and that changes the shape. So I get a single sequence, right? Which means that this future that I'm returning will be complete only when all the constituent futures are complete. Right? It will fail if any single fails. Right? And that is the semantics. If any single fails, it will fail. It will contain the exception, and it will succeed only when all of them succeed. Right? So with this, I should be able to test this. Let's see. So now when I run this. Okay, so what are you observing? I mean, you have how many numbers? 20 numbers now instead of 10. So it's going ahead, but something happened. I mean, the 4 calls happened, and then 1 happened. Right? Anyone can someone guess why it's happening?
The number of thread was 4.
Right.
Initially consumed 4 threads.
Right. So this is a test which is basically demonstrating the limits of your system. Right. There are 4 threads, and you're blocking. So if you're blocking, then first 4 operations will start, but even before they finish, right? Until one of them finishes, the next one cannot start because the thread is being blocked. So that's what I was saying, that this was cheating. My API is async, and I'm able to achieve some level of concurrency, but this is completely useless concurrency because it's just one call, and all your system will come to the halt because there won't be any thread availability. So async APIs does not guarantee that your calls, your implementation is not working, and that is a central point. I'll show you. Nice chart about that. So that was about the async. So what do we do if you really want this thing to be non-blocking? What do you do? I mean, any ideas? How will I implement? I mean, my signature will look exactly similar, right? Async and non-blocking signatures will be exactly similar. Right? You're in Java world, right? Or even any language world, right? What is the equivalent of delay? So you know what is the culprit? What is the culprit so far? Culprit is a delay, right? Which is in the blocking, and where is the blocking? Yeah, here, sleep, right? This sleep call, right, is the culprit because that blocks the thread, correct? So what is the non-blocking equivalent of this? How can you delay but still not block the thread? Can you? I mean, you can't. I mean, it's just simply not possible in any language because this like doesn't make sense. Right? You want to delay. So the equivalent of delay in a non-blocking word is scheduling. So you say that okay, this operation has to be scheduled after some data which was nonetheless 5 milliseconds, right? And that's what we are going to do. So of course we'll need some help from the library, but we'll see how to do that. So we'll begin our transaction, and then we'll say that okay, a scheduler schedule this as give me back a future after this delay, and then inside that schedule scheduled job, I say that I will compute, and after my computation is done, I will say that print, and after I print it, I will return the result. So now this is similar, but also very different. There is no thread.sleep. It's not possible because that was the main filter. I can't use blocking. I have to create my own. Right? Is that clear? This API is clear, right? So what is it giving back? Giving me back a future of t in this case, a result which is an integer, right? And this is fine. Of course, I need a way. I need a way to schedule a job and also get a future back. How do I do that? So there is some validation, but I think it's important to understand the API, the future and promise API. So of course, I am on the JVM, so I have to make use of some JVM utility, and but the JVM utility is a callback. So there is a scheduler on the JVM which takes a callback. Right? It doesn't return me a very meaningful thing. It does return something, but that's not very useful. I'll show you that. So what do? I bridge this callback word. Callbacks are not good, according to me and according to people who use this kind of model. Callbacks are not good because it's difficult to reason about. They are not values. They never return. They ask you to go inside, right? They never return. So composing is difficult. I can't say that okay, a callback to square and a callback to increment and write a new function that will compose. It's not possible, right? We have to enter the callbacks and it's a big mess to reason about. So to bridge the callback word, and callbacks are essential, the events are essential for not blocking, because scheduling is an event, right? So to bridge this word of callbacks and values, there is something called as a promise, and I think this programming model with it. So I create an empty promise, right? Unlike futures which are immutable, which you can only compose using combinators, promises are right ones. The kind of mutable, the right ones. If you try to write second time without exception. So you start, the pattern is like you start with a promise. Right? You declare that, okay, there's an empty promise. And then you convert a callback like a runnable. So this is a Java runnable, right? So I'm defining a callback runnable. And inside that, the run method is basically fulfilling this promise with my block. So remember this method, how was it used? It was used with a delay and then a block, right? So this future method takes two parameters, a block and a delay. This is delay, and this whole thing, my logic is a block, right? And that logic is what is captured in the block here, right? So what I said, okay, I mean, call the block, but call it inside this. Forget about try. It's about handling the error case. And then say that, okay, with the result of that block, complete this future. And that's why the complete this promise, and that's why promise is of type T, because my block is of type T. Right? And in the end, the pattern ends like this. You say that, okay, well, I haven't scheduled the runnable yet. So I schedule the runnable. This is the API of the thread pool. And thread pool, as I told you, is coming from the Java. Right? So thread pool has a schedule method. It takes a runnable. And it takes a delay, basically. It doesn't have a delay object, so it takes basically the length and the unit separately. So I'm separating them. After my scheduling is done, in the end, I return a value, and which is the future. Every promise has an underlying future. The immutable version is called as future. In the JavaScript world, if you see promises and futures, they are same. So what you float around, right, are the promises where you can use them like future, and you can also use them like promise. You can write. To make it slightly safer here, what we have two ideas, but every promise has an underlying future that I've written in. And this is the way to convert a callback-based system, underlying JVM, into a value-based. But instead of returning a T, I'm returning the future of T, because just return T is not possible. So this is in brief. How any questions so far? I think I talked.
So this promise object, like JVM or Scala.
Right. So promise is Scala standard library. If you notice, the written type of schedule is something called as scheduled future. This is Java. And I wish it had all the properties. So then we don't have to do all this. I would have just used it, but it doesn't have. I'll show you that. I need a lot of combinators. Java 8 future hopefully will have many of those combinators, right? Complete future will have those combinators. This does not have this at this level. That's why I have to wrap it up. And I'm using promise and future, which is Scala standard.
With feature, you are able to schedule, right? But again, for the result, you have to wait or you have to. So that again, it's a blocking.
I'll put it this way: that in future, I can't schedule. I'm able to schedule with the scheduler which Java library provides me. But to schedule that, I don't want to enter the callback word. So what do? I say that again. I create a promise, and I say that after that schedule, right, whenever that event happens, right, complete my promise, and I return future immediately. Which means that when this call is being made, I get my future immediately. It's a future of integer, but it's incomplete future. Fortunately, in the Scala standard library, there is no way to say that okay, get you the value of future. Otherwise, you'll be blocking it. So there is no way. I mean, if you're using future, there is no get on a future in Scala, right? The only way to combine future is via combinators and callbacks. So at that time, when I just get it back, it's incomplete. And if I put any callback or any combinator, that will not move forward. But as soon as this promise gets complete, the associated future will be complete, right? And then the machinery will move ahead. So this is like a data flow. You know, if you understand that, this is a data flow, right? This is the way of doing concurrency, which is data flow. One thing completes and then it triggers the other, and I don't have to explicitly.
Again, you have to wait for that thing to complete and then you to get it.
Right. Let's see how we wait, because I said that there is no wait. There is no. I mean, of course, in the test, so that my test don't exit, I have to put a wait in there. But in my application, you will see that there is no wait API. There is no get API. So you will see maybe this is a point where we maybe try to understand how this whole usually is working. But there is no wait. It's only that I will put a combinator and it will move that internally, right? And you will see once we consume it. Okay, so I think this is good, right? So let's go to our test, which is here, and in the non-blocking, no, this is multiple squares. So I'll go to the single square test. Let's see. This works. This should work exactly like SC. If you just do this part, there is no difference. There should not be any difference in the output of AC and non-blocking, because their characteristics are same. The implementation is different, right? And we are using just a single call. So single call returns immediately. Okay, here the begin happens, but that is immaterial. End definitely happens after my call is begin. Now the real test is bulk operation. So we saw that how this bulk operation is a problem, right? Here I'm doing exactly same calls, same batch, same size, and we can call back that after it is complete. Let's try to implement this. Here, this will be very trivial because once we have underlying mechanism for a single, this logic is very similar to what we did for async. There is nothing new here. I could create an abstraction which is common here, right? And this gives me back what I want. So at this point, if I now model this, right? So this is different. Right? This is different. The difference is that all of them are scheduled together. I mean, they begin together, right? I mean, they just begin and they all begin and return. All returns right, immediately after. That happens instantaneously. I mean, I wish there was a timer so to see that. And then slowly the things start completing. But you know how many threads are being used in doing this? We had only 4 threads in the whole system, right? So how many threads are being used here? All 4? More than 4? Less than 4? We don't know. We don't know which threads are being used. But what we are saying is 4 is not required. So if you now go to config and if we make it 1 and run the same test, this should still work. Do you agree? Because the whole design is basically non-blocking, right? It's a scheduling act. I mean, I'm not consuming a single resource. I'm not making any thread.sleep call. Right? And this is how the Node.js works. So in JavaScript, how many threads do you have in JavaScript by specification? 1, right? I mean, so and how does it work? Because it works this way. And that's what I say that the JavaScript guys really understand this well. But the JVM guys, there are 2 dimensions in scalability. One is within the thread, the way we are doing, and one with the thread pool, right? So people always confuse this async non-blocking and stuff like that. But this is pure non-blocking. The test is that all the discussion, if people disagree that okay, I mean, what is non-blocking and blocking and you should always the real discussion should say that okay, let's talk if you have just one thread and you want to do an operation. And if conclusion is that okay, well, this operation will proceed one after the other, then you are blocking something. That's a real lesson. Any questions? I think the one important part of my talk, I think I'll just try to summarize here. So what we're saying that async and non-blocking are different things. Async is about API and non-blocking is about implementation. And async API can be implemented for blocking calls. That is what we did first. For non-blocking calls, sync API is not possible. I mean that is a bit of a I mean that's the next thing I wanted to tell. But for blocking, I mean this is just basically a way of presenting. So I'm saying, you know what, for blocking, if I can create a async API. But if my implementation is not blocking, there is no other way. Why? Because non-blocking will involve something like scheduling, something like a fallback. And to give it a type, I can't give it a type T. I mean, try to implement that more schedule also. And you want to return without any blocking, all you want to return the value of T. You will not get. I mean, it's not physically possible to do it that way. But you can fake it, or you can use some library level or a language level things like macros and sequence transformations and fake it basically in the types or in the library to simulate as if you're doing a very imperative blocking style, but interface is not blocking. So this cross right is usually not possible, but yeah, you can. That's why in C#, have you heard of async await in C#? So C# has 4.5 has async await. Which is a very nice, direct, imperative way of programming operating systems without blocking, and which means that this XXX thing, right, is actually possible, but it needs a lot of effort and machinery, and it's like that's not our focus. So our focus is like, okay, for blocking both the APIs are possible, for non-blocking only feature based on our non-blocking APIs. So that concludes the first part. If there are no questions, I'll move on to the second one.
Just a quick question. So my understanding is that in headline you could do a non-blocking.
Yes.
Because by nature it is non-blocking.
Unlike is definitely non-blocking. Unlike is like so we are talking of a fancy API, like value-based API, which functional programmers will enjoy composing because it gets your value back. So I have a square function, increment function, and futures will compose. Maybe we'll see that later on. But the underlying machinery is called back here, right? And if it is not called back, it has to be message passing somewhere. Akka and Erlang will be message passing. For example, if I did not have this, JVM or scheduler was not my primitive was Akka actors or Erlang actors. I will use them and then wrap them into a future API. The difference, maybe it's an industry difference, that Erlang is an extreme system where everything is an actor and everything is message passing. So there is no non-actor word in case of Erlang. But in Akka or on the JVM, there are callback or actor word, and there is a non-actor word. For example, your my methods, all the methods that you saw, it's a non-actor word. It's not active. But so the bridge between the actor word and non-actor word has to be via value, right? I mean, yeah, I pass a message, but what do I get back? I'm not an actor. I don't have a mailbox. I'm not going to get. I'm a simple object. I'm not going to get a message back. So the connection between the actor word and non-actor word is via a call in case of Akka, which gives you a future. So that's an interesting connection, which does not actually exist for Erlang because they don't have a need, because they are really pure in their philosophy, and they always work by message passing, not by never outside actors. Okay.
So is it true then that in Erlang you can't have synchronous calls?
Actually, there are no calls in Erlang, if I'm correct. The notion
Message passing.
It's message passing. So what you do is tell. What you do is tell. You send a message and you expect that actor to do something. It's very frustrating to see the signature of that call. The tell call is basically X anything. Right? The input argument for tell is basically anything, because you know what? Currently, the actor is capable of handling these set of messages, which are also very heterogeneous. They will not work only on integers or only on person. So, and in future, the actors could be hot swapped also, right? I mean, I can in the live system, right? I can change the behavior of an actor. So input argument has to be anything, and the return is unit, which is void. right? I mean, because I'm telling, right? So I just make that call and my contact is over. That's the guarantee that, okay, I pass a message. Whenever you pass a message and you want to return immediately, it has to be void, right? There's no other type possible. Of course, futures are possible, then futures do not exist there. So the whole programming model in Active is extremely object-oriented, truly object-oriented, which some of us hate now, the tell don't ask, right? Which is like always tell, always side effect. That object will take that whatever you're told and then do something with other object, right? So actors basically follow that philosophy to extreme. In Actor, it's always tell don't ask. Actor is an extreme implementation of object orientation, if you will. Right? There's no query. There's no querying. I cannot say that this object and I make a call. When I say make a call, I'm expecting a value back. I mean, that scenario does not exist. It's always a message passing in the void. I would say it could be very true because having programmed a little bit with Akka, it's a very frustrating model. Right? I mean, it's a very low-level model. It has very good properties in terms of distribution, fault tolerance, and all that. But in terms of user friendliness of the API, right, and reasoning, it is very complicated. There is no reasoning possible. Right? I mean, it's a very different type of reasoning. At least I don't get reasoning. So I think that's the difference. With that, we'll go to the next step. Let's see. The next step is the inner demo. So I'm going to go to my squares method. I have a blocking now. Now we want to do streaming, right? So, have you heard of RX Java? You heard of RX Java? Netflix, reactive extensions. Have you heard of reactive extensions? .NET. So this is again from Microsoft. Things from Microsoft, right? And that is being now done on Java in Netflix, and that library is called RX Java. So it implements similar concepts, right? Of value-based programming, composable programming, but not for a single value, but a stream of values. Right now, if you notice, our API is very limited. If you notice, the API feature is limited. It holds one value. If you have multiple values, it has to hold all multiple things as a single value, which is a sequence of integer, which is a single value. It's not a stream, right? But if you have a better API, you could say that, okay, you know what? It's the stream. As I'm squaring, I'm getting my values back, and maybe I start summing it up or doing some streaming operations, right? Or actually start moving object over the I/O to some server. And that is what the streaming API provides you. I'll first write the test. I mean, test is there already. So here, what we are doing is similar to the non-blocking. I'm calling this streaming square or streaming, but a single value just to show that how it's implemented and just to show the call data immediately. I have to do this blocking just in the test. In the app, you go to blocking and then yes, okay. To do this, I will implement it. So you begin a transaction. Okay, well, here you need a scheduler, of course, but now the scheduler needs to return me a streaming equivalent of future, and we'll see why it is named like that. So what we're doing is very analogous to what we did for future, right? But I'm saying that instead of a future, give me observable. But it's very now misleading that observable, I mean observers and all that. But if you notice, there are callbacks involved. So name observer is not very out of place because observer also has a callback. But here the observable is a streaming object. What a future could do with one value, observable will do it with a stream of values. And this name comes from the reactive extensions API and RX Java. I'm using RX Java, and because I'm in the futures world, I have a small util basically which will do the conversion. What is happening here is very simple. My util will just create a future by delegating to as future and then wrap it into observable for a single value. Right? This is very simple. And the single value you won't even notice a difference when I run this. So if I now run this, the effect will be very similar, but the effect will be evident once I do the bulk operation. Right? So call returns immediately, and then the result returns later on, which is as expected. So more interesting thing is a bulk operation. So how do I do a streaming work operation? Okay, there are a couple of things possible here. Let's see what I will do is this. So similar to on complete on a single feature of a sequence, you know what was the type of result here? A feature of a single value, which itself is a sequence, complete sequence. Either you have exception there, if it is failed, or you have a complete sequence there. There is no notion of one value at a time, right? Here, what I'm going to get is an observable of integer, or maybe you change it slightly just to keep the analogy. And on that, I'll have to subscribe. Right? That is again a term coming from the word of observers, right? Subscribe, which is very similar to on-complete. The difference is that on-complete it has a notion of okay once. Subscribe has a notion of on each event, right? Subscribe. I mean, on this could be called as for each, this could be called as on event, on next. I mean, it's a similar semantics. There are print line, and this is just to make the test complete. And let's see how to implement a streaming version. Well, not very complicated actually. Very similar, but I'm using a library basically to wrap, and I'm going to do couple of changes quickly so that you get the analogy here. Okay, so what we are doing here is called delegating to streaming for single value. Hence, instead of futures, I get observables, which is sequence of observables, right? Sequence of observables of type integer. But of course, I don't deal with the sequence. I have to top level has to be a reactive, otherwise I can't compose it meaningfully. So what do? I wrap similar to feature of sequence. I say observable from library method to create, and now you see the analogy there. Right? So future of sequence of it. Here it is observable of it. Seems that we have more capabilities to work with. Right? Let's see how we can make use of it. So with that, I'll go to the test. Now I have now this is an observable of this thing. But to work with the single observable, I have a couple of options now. Right? As the values are streaming, now I need to decide how do I need to. So there is one property in the future-based API that the order of the sequence will be preserved. There is no, I can't expect that I give a sequence 1 to 10 and my squares are coming in a sequence as a single value but different order. I mean that is a rubbish API. So that API is okay, very easy to define. Here I have some flexibility because I have observable in. I can say how I expect the data to come, and I'll show you what it means. So in fact I'll call this O because this is a observable, and then what I will do here is I will define another value, a result O. Is equal to this dot concat. So concat is one way of saying how to combine, how when they are coming, and which means that in order. Concat means in order. Right? It will have very interesting implications that we'll see. Let me run this. Hopefully this should work. We have 4 threads. I think I have changed that, so that doesn't matter. Even one thread would have worked, but we have 4 threads. Right. So all of them are scheduled, and this is all fine, right? We're all fine. But there's something interesting happening apart from the log statements. Right? There's another thing which is happening here, that I'm actually getting the squared values back, right? And that is due to the subscribe thing that I put, right? You agree, right? That is because of the subscribe, right? On the squares, right? And interestingly, squares are coming in order. So I get 1 and then 4 and 9, and then that's the reason. If you notice, well, I started and ended squaring all these numbers, right? All these numbers. So I already have square for 15, but what I'm printing is just 1. Why? Because after 1 I am expecting 2, and unless 2, my semantics of concat is that unless 2 is available, I can't print the next one, and 2 unfortunately comes later on, which means that the transient memory leak happening, right? I mean, this has to be. Of course, you can say that in future API, it was obvious. You're saying that the sequence will load in them. Here, it may not be obvious. You say, oh, I was streaming and getting my data from here and putting it on the server. So your mental model will be like, okay, very lean memory. But here in concat, depending on how operations happen, that's why there is a randomness we put, right? It's not 5 seconds. It's like random value. then comes 4 and 9, right? And then comes, so you get the picture, right? You get the picture. Cool. But there's another way I can combine this, and which is flatten. So if I say flatten, let's see what happens. So this should, right? It begins, but you know what? Now it is saying that okay, I'm creating the values as I get them, and that's why I'm not printing the last one. I should actually print the last value also, and it will show you that it's coming in some order, a random order. So this I can print. Why don't I print this? Print line. This should show you that it is coming in random order. Right. So this is really powerful. I mean, this is really reactive and non-blocking, right? I mean, because of this observable thing, which has the capability to give you a stream of values, you can really make use of the scenarios where you just have to. You're in many cases, right? You have to say that okay, from internal server you have to load it to the external image server, right? And very common use cases, and this will work perfect in those situations. And all this is possible because the container itself has that capability which Future does not. So, so with that, I think I want to. There are a couple of other interesting things about the error handling. Maybe I'll quickly show you. So what I will do now is go to Square and introduce an error. So happy path. So error handling is also a little bit better here. So I can say that okay, by deliberately say that okay, if x is 12, then you throw an error. So throw exception. Otherwise, you just square it. Cool. So if I do this, and if I run my test, right? I mean, now there's an error midstream somewhere it's happening, right? What is the result? So let's say I use concat. Let's observe how it happens. So concat is similar to the Future because the order is preserved. That's why I'm first using for that as an analogy. So well, it starts, and then some of them should finish. Yes, some of them are finishing. And there's an exception, right? And the others finish, and then program just terminates here, right? Which means that there is a partial success. There is a partial success, right? I mean, I might have received values which are beyond 12. But they won't be of any use because by definition it's sequential and the error happens before at place 12. So what are the other alternatives? If I say flatten, maybe I'm slightly better. If I say flatten, because I'm just saying that as soon as you get it right, given the value, so maybe I will slightly have more data to work with. It will be inch better. In case of Future, it was all or none. Either you get the whole sequence back or nothing, right? Because there is no notion of a sequence with an exception, right? I mean, there can't be sequence with an exception. But here there's a lot of possibilities, and hopefully I'm getting here more values. What is more interesting is that because it's the nature of the API, it will give you more interesting combinators, which is like flatten delay error. So you say that okay, flatten, but you know what delay error? Because the semantics of stream is that there can't be an event after completion or error has happened. So there are three callbacks on observable, which is on next, okay, and then there is on error or on complete. Only one can happen, on error or on complete. And once that happens, on it cannot happen. These are certain guarantees. These are the guarantees of the API. But if you do this, maybe you're really well off because you will get a lot, all basically you'll get all the values except 12, and that 12 will be the last one. But still, it will throw an exception because we are not doing anything. I just try to use slightly different variation and see if I can. There was on error, so there was on error resume next. On error resume next, and this takes an observable, right? So if I do observable of empty, what happens? Observable. Okay. So if I do this, I'm hopeful. I haven't played with this API a lot. We haven't used this on our project actually, but this is very much related, and that's why. Cool. So this is really nice, right? I mean, what I'm doing is I said that okay. So, first of all, I'm saying okay, delay. First I'm saying delay, and even after delay, I can combine and say that okay, I am putting another condition saying that okay, once you encounter this error, replace it with this observable, right? And which means it's empty, so no action, but completion signal and not an error signal. And because of that, my code will continue. So that's why you see now on this being printed. So pretty nice idea. Now it's not only that because we want to deal with a huge amount of data, streaming is necessary. Streaming becomes mandatory in cases when streams are infinite. I mean, then you don't have an option. Right? For example, Twitter stream. If you have a Twitter API or any streaming API, the streaming API will not terminate. Right? I mean, it's like okay, it's a tick of a clock, right, which is happening, and you some service gives you that. Right? It will never terminate. In HTTP world also there is a way to give this API using a chunk response, right? So you don't say that what is the length of your response. You say that okay, well, I am going to give you chunks and then keep giving chunks. So there is no end. So that is Twitter has an API, so that's why I have tried to create a demo. Hopefully it will work to deal with that API. And now you will agree that to deal with that kind of API, streaming API. If you want to deal in this. I'm not sure how you will deal it in a blocking fashion at all. I mean, if you just deal with threads and by hand, infinite streams, I mean, it's very difficult. It's very difficult. I want to talk about that. Cool. So what I'm going to do is just open a Twitter client. Here, right? So this is a JSON API. This is not a JSON API. It gives me JSON. This is a streaming API on Twitter. It needs some authentication which I have created. I have a utility method here which says that sometimes your updates will not be status updates. It may be deletion or other updates which I want to filter out. So I created a small function which is saying that on this JSON, look for an ID, and you should get a long value which indicates that it's a status update API. Right. So if I say that okay, if you get it, which means it is defined, it is a status. And on that, I have created a small client. I'll show you internally, right, how it does something, right? But this is fine. It's doing some authentication and converting between the plays APIs, which are very complicated enumerators and iterators, into nicer RX Java APIs like Optical, right? And what I will do here is at this point, what I'm getting is basically JS objects. Okay, I'm getting JS objects. And what I will do is just do the last one now. Okay. And what is here? Yeah, here is some sleep. So that this doesn't terminate, right? So I'm going to subscribe to these fields, which are currently only at JSON, right? It could be a string also, depending on how I pass. I'm passing it, knowing that it's JSON, and separating it, and printing it. Let's see how it works. Hopefully. So this is live, and this stream should not end. Okay, cool. So it's passing correctly, right? And this will end after 15 seconds because I'm terminating my test. Otherwise, this will never end. Currently, this is just a JSON, right? And let it stop. Okay, it's stopped now. So you see that there are some delete statuses also, right? Where the ID does not exist at a top level like this. This is a top level ID. In delete, you know what? It's inside, right? And then I want to just filter them out. But before I use this, I will show you a better a way of programming this, right? So now what I will do is, forget about this. So this is a string, and you all know collections from functional programming, right? That is all collections and compose string. Well, those ideas will apply to streams also, because streams are nothing but a reactive collections in a way, right? They're just reactive collections. So what you're saying, okay, get these streams, but filter out these ones, right? So that I should never see now at this, just with this, I should never see a delete status. I should just see the status that I'm interested in. Yeah, I can scan. So good. So this is fine. Very strong. Okay, it's stopped with some error. I don't know. I hope next time it works because Twitter stream, right? if you call it again and again, sometimes it gives you at least it gives you a problem. Now what do I do here? So any question?
Blacklist your frequencies that
Yeah, if I do very frequently, they will definitely do that. So what I'm going to do is now transform this JSON into my domain model, and that is I'm doing this just to give you a feel that how easy it becomes to program, right? So my domain model is like, okay, I want to work with a tweet which has these things, ID blah blah, right? And then I just pass it. So I get a JSON, will this take a JSON and pass it and populate my domain model, right? It will give it. And that's what I'm saying. I'm saying map. All of you are familiar with map function, right? And just say that okay, on this tree, map. So instead of now observable of JSON, I get observable of tweets. So this becomes a stream or my collection, reactive collection of tweets, my domain model, right? Which is pretty neat. And I'm just going to now print that. Let's see. Okay, good, it's working. So we are passing and we are converting into our domain model, and I'll just show you why it is our domain model, because the two-stream representation will have some specific things, right? So this is the two-stream representation of my model, right? So I can actually extract the different parts and work with that. That is the next thing. So the next thing what we are doing, okay, we are not interested in all different languages that we saw. We are interested only in English language, right? Now it is as simple as saying working on your model, right? You again filter, but now using your model, because lang is a part of your model, right? We say that okay, filter out all those which are English and nothing else. And if I now use it, you should see what English means. Cool. So that is it. I mean, you do see some Arabic and some other characters, but they in their JSON data they label it EN for whatever reason, and you can actually see that. So all of them have EN there, right? That's the basis of filtering. You can do a lot of other things, but I think you get the idea, right? How I think we are almost 1 hour. I have another demo which does not need authentication, so if you want to play with that, and there's a very nice online chess thing which is called a chess. Have you ever seen this? No. Right. So this is a very well designed site, very responsive also. This is done using Play, and Play is streaming APIs using utilities and all that, which according to me are pretty complicated. But if you find on the internet, or if you look at the GitHub repository, you'll get a connector how to convert your Play APIs into RxJava and use it. So it has a streaming API. So if you say stream, it has a streaming API which does not need authentication, and somehow it is not rendering in my Chrome. It used to, but it doesn't render in Chrome. So the first one is the username, and it is chunk. It is chunk. This is a chunk response. So if I let it go, right, and unless Firefox has some smart way of clearing the memory, I mean my machine will crash, or my Firefox will crash, right? Because this will keep on going. Okay, this will never stop. This is the stream of all the moves which are happening. They should give the moves right now. They just give the username and the IP address from which they are. Many of them are robots. Basically, the site has robots which play with the actual players. So if you want, I'm just going to close this. If you want to see this working, I have that here. So you go to chess. And you can do a lot of interesting things. I'm just going to show you the possibilities here, and then you can write yourself. So what I'm doing is instead of JSON, I'm passing it like a line stream. Strings, they are not JSON. And then I am converting it to I'm calling a factory. Again, my domain model chess, right? And some handling here. Interesting things on the streams that you can do, right? Buffer. For example, you want to say that what is the histogram? How the site is? What is the running histogram of the chess move every 5 seconds, or maybe say every 2 seconds. Right? Every 2 seconds. What I'm saying? I think it's instructive to look at the types. So at this point, I'm getting an observable of chess move, correct? A stream of chess moves which are coming to me. But I say that, okay, hold on, buffer it, and this is part of the library API. Buffer it every 2 seconds. Any guesses what will be the return type now? Observable of buffer or a sequence of observable of a sequence of chess move, right? Because the buffer value will represent a chunk or a group, right? Which is sequence. And on that, I do map, but this map is happening on the observable, which is the outer container, right? And the size is happening on the sequence, which is the inner value, right? I said, and this will give me the potential, the running histogram every 2 seconds. I think this works. Okay, it's not working. It's not working. Oh, yeah, it is. Sorry. I think I should do this. So this is telling me for the next 15 or 20 seconds, it's telling me that in 2 seconds, how many moves are happening. So around 100 plus moves are happening. So it must be robust, right? I mean, it can't be so busy. And this is a very nice example. I mean, you can just connect this API, which is anyway reactive API, to your UI widget, right, on JSON, and you will actually see and that's why many demos of Play and that you will see will actually render some JavaScript which will connect to these APIs, and in real time will render that is what this site is doing. If you observe, right, that is what this site is doing. So all the real time updates and all the moves which are getting updated on the left and right. It's all real time based on the stream API. Okay, so that with that, I will just go to the slides and see where we are. Okay, so what we okay, no, this we did not cover actually. Sorry, there's one very important thing I did not cover. How much time do we have? We can continue for some time, right? Okay, so I'll show you what we covered. Okay, what we covered is this. Error handling is feature is a bit difficult for the bulk operation. Either it is all or none. Observables are nicer alternative, but there are a lot of because it's a streaming API. You can do a lot of things like retries, timeouts in a very nice way. Observable API does not support backpressure. This is very interesting. So I talked about this in the Scala Symposium in April, and just within a week, right? I was aware that people are working on backpressure with the stream, and then these people, RS Java types and all that, they started initially for reactive streams. Have a look at that. So reactive streams is a connected sub page. It does refer to reactive manifesto, which is kind of marketing side of the technology. And then but the object is really nice. You notice what is the problem with the stream that we saw, right? It can overwhelm the consumer. So we are consuming it, right? People is sending me, I'm consuming it, right? But there is no notion of backpressure inbuilt in the RX Java or the reactive extensions, which means that it is dangerous, and that is the reason why Play does not use that API but a slightly more complicated API in which the backpressure, which means that I can be overwhelmed, right? So for example, there is a pipeline of stages where the streams is flowing, and one stage is slower, right? Which means that data will accumulate somewhere. A stage before, data will start accumulating, which means that memory leaks, right? Which means unpredictable server. If you're implementing your servers using streams, then which means that okay, it's not very robust as it could be. So the objective of this project, Reactive Streams, is to have a similar API that we saw and similar notion, but with a backpressure, and RS Java is part of that. So hopefully the next version of RS Java should have it. The streams, Akka is being wrapped into something called as Akka Streams, which will give a similar API and the backpressure and the distribution. So this RS Java is not, I mean, of course, it's not meant to be distributed and all that. Akka Streams will be distributed. The next version of Play will be using Akka Streams via API called Akka HTTP. So Netty will be replaced. Netty will be replaced completely with this new idea. So it's very ambitious. Let's see how it goes. But I think you should definitely, if you're interested in this, you should follow this. There's a GitHub project. You can follow the issues. There are a lot of big people who are involved in this. So some of them you might notice. So there is to it and lead also here. Yeah, there is he's here. Take my from he doesn't participate a lot. But, Mr. Todd is very famous guy. Couple of types of guys, graded guys, right? So you should follow this. So that is about the streams. Now I want to go back on the futures, and one part which I did not cover, I want to cover, right? And then I want to demo using a mixed test, and I think this is much more practical and that we dealt with than the stream. Right? Now what I want to do is, I want to demo the property of blocking, right? Which is contagious. The blocking is contagious, and that is what I want to demo. And that's why I want to say that if your systems have to be end-to-end non-blocking, you can't say that, okay, you know what, just this one part of our system is blocked. And if you have that, you have to take extra care, and I'm going to show you if you don't take that care, right, what can happen. So what we are going to do is the first part, right, is a non-blocking call. So 1 to 20, right, in a non-blocking fashion. And the next one is async. Remember, async was cheating, wrapping the blocking part, right? And I mixed it. I said, okay, I first make that call and then make this call. My API has futures anyway. Any guess what will happen? And I await for both of them, and I start printing. Let's see. I cannot run this in a long time. Let's run this. Any guess what will happen? I have beautiful non-blocking implementation there, and then blocking implementation. So I'm expecting non-blocking to work, but it will not. Right? It will not. Why? I think in retrospect, it's very obvious. So what is happening? But non-blocking calls, 20 of them, they're starting. No problem. They're starting. They just need a fraction of a thread, if you will, right? But as soon as in my test, if you observe, as soon as I'm done with that call, I make the next call, right? Once I'm done, I put my call back. I do the next call, right? Which is async, right? This call is also trying to trigger 20, and it will be able to trigger 4, and it will hog the entire system resources, which are the 4 threads. So even though you had nicely written most of part of your application in a end-to-end non-blocking fashion, just an element of blocking in your application can infect, and which means that, okay, in other words, if you have like 100 web pages, only one web page, right, where there is a JDBC driver call, which is blocking, right? JDBC by nature is a blocking call, and you're using it inside a play, and you say, okay, blocking only for this is, and I will wrap it inside a future and continue. It will slow down the entire system. It will slow down the entire system, right? If you don't take care. So what is the way out? So the way out is in execution context. So remember we looked at execution context here. We said that when I'm making these async calls, right? When I'm wrapping them into futures, there is this execution context, right? And if I ask idea which one, it says that, okay, this execution context is being passed, correct? So compiler will pick it up properly and pass it for me, right? And that is the single thread pool, right, which is being used, single system. What we need to do is divide it into 2 systems, one for block, separate lanes, right? One slow lane, one fast lane, if you want to understand that way. And how do you do that? It's very simple. And this is the kind of stuff which is very much encouraged in these systems like play. Right? It's not okay. I mean, because server should do it, you should not do it. No, you should do it if you are mixing the blocking. So if I have a JDBC call to be made, of course I will wrap them in futures so that I get some level of competency. But I will also wrap them in futures because I can pass them the custom thread pools when I make my future call. How do I do that? Okay, I say, well, my blocking config, right? In fact, it should not be like this. It should be like this. In the real world, it's like this. When I have JDBC calls, right, I do a thread pool of 300, 500, right? I mean, it's a very different number. Just assume that here I will give it a 10. Right? So threads of 10 threads. So I'm creating 2 configs, one for blocking and one default, right? What I have imported here is the implicitly what I imported here is the default. But I will ensure that when this blocking is being passed, right, I give it blocking config dot execution context. Right? So now I'm giving it a separate lane explicitly. I know in my application, in fact, I will cover So my blocking and non-blocking code mostly will be in different files, and I will ensure that I import different things. If I'm mixing them, I'll ensure that I pass one of them explicitly. And if I do this, hopefully our problem should be taken care of. Cool. Yeah, this seems to be working. So, which means that now all start for non-blocking immediately, right? And my results also start coming, right? You see, so many results are happening in together, right? Next one will start being picked up. So I'm finishing, and some of them, I think my failure condition is ending the streams are there, right? I should remove the failure conditions so that you see the results, and that is here, right? Maybe I should say that we don't know failures. So you see that, okay, because now there are 2 thread pools. In one case, I just need one actually. If I guarantee that it's really non-blocking, I just need one. Okay, and then in other I have 10 or it could be 300 depending on and the whole app. I mean, just one web page or one part of the application will not slow down the other part, right? So this is the output. I hope you got that point. I think that was important, and that was the point here, which was blocking is contagious. Execution context helps quarantine that infection, and separate execution context for blocking and non-blocking is like different lanes, speed lanes. Okay? And with that, I covered everything. One more table, just to now blocking instead of blocking and non-blocking, I have single and multiple, and then I'm trying to compare the observable fusion. Some of this is inspired from the tables that I saw on the RX Java page, which are pretty helpful to understand. Some other equivalents, but I think you can ignore that for the time being. And this code is there on the Pune's Scala Symposium project. If you go to my GitHub account. Yes, and it's like last slide, we use Scala a lot actually, and we teach corporate as well as free training. We recently conducted the free training, 4 full-day free training in ThoughtWorks. But there was a process. I mean, we give a coding test and people submit coding test, and that's how we select. 350 people registered. 95 people submitted the code. There were 2 small problems. 95 people submitted. 30 people we selected. 29 people attended on 4 days, and 10 thought workers. So it was a match of coding. So yeah, with that, if you want to follow more about what we are doing, Pune Scala is on Twitter handle. Pune Scala is also a meetup in Pune, and Pune Scala is the mailing list. Cool. That's it. Thank you. Okay. Questions? Yes, questions. I mean.
So you mentioned that you're using Scala widely.
Yes.
So I'm interested to know which are the areas in the real world where Scala is most popular.
So my opinion is different, but I will tell you how people are taking it. People are definitely liking this reactive things and reactive API, right, which is really nice, which is very vibrant. The whole ecosystem in Scala community around these kind of APIs is very vibrant. So for concurrent systems, for scalability, for reactive systems, Akka is very popular. Even though we are not heavily using it, we are using it just for very, very small state-related operation. Akka is very popular in the systems which need pipelines and stuff like that. And Akka scales a lot. Actor model scales a lot. I personally find that model difficult to program, but that's my opinion. Akka is getting a lot of traction. So in those kind of things, Scala is getting real traction. If you ask my opinion, I think Scala is suitable for everything that Java is suitable for and more. So it's up to you how comfortable you are and how willing you are, what kind of team you have when you decide that. That's Twitter is using it quite heavily. Oh, Scala is being used a lot. I mean, if you see a page, there's a page on the TimeSafe. You must have seen that, right? TimeSafe. There's a huge list of companies. I mean, I think Scala is beyond that thing. Who is using that, right? I mean, there are banks in Pune. There are many people using that. I mean, we get requests that, you know what, from a services company that came to train us in Scala because you know what, we're working for a bank and then they are using it, they want to use it. We have got multiple such requests. So they're definitely using it. You can see somewhere here, there's a huge list of community resources. We use case studies and stories, right? It's nice. So Walmart is using, LinkedIn is using, Twitter is using, and there are case studies. It's not just the names, right? There are full case studies. Coursera is using, the whole Coursera site that you interact with is in Scala. Play actually. News sites are using, Guild is using, Guild is a big brand. Foursquare, of course, it was very old. Guardian, I mean, we have worked with Guardian currently. So Xavia is a services company, you may know that, right? I mean, they use it a lot. Lots, there are lots, I mean, and this list is not complete. This is the list where people are willing to create a case study and put it. Banks usually won't do that, but many banks, I mean, they're using it. So Scala is beyond that point where people are just using that, right? I mean, it's much beyond that. Any other questions related to the topic or in general? I mean,
about scalar training, on the email circulator, we had mentioned that maybe Coursera course you should have taken.
Right, I wanted people to have some investment done. Right, I mean, if people come here in a training without getting some familiarity with the syntax or some ideas or some inhibitions, right? Most of the attention goes into that, right? Okay, but why the syntax is like that? But why is it like why the language is like that? Or how does it come back? So I wanted people to get over that by the reading some part of the book or taking the course. I would say that the Coursera course is very important. I mean, not for Scala, but if you want to learn from Odrisky, which is he's a great professor, I would say, is a very good course and it's a bit theoretical, but it's a nice foundation. At that point, I think you should be ready. You should say that, okay, I learned that, but you know, I don't know how to apply that, and I don't know how to understand these ideas in terms of real life projects and the real dirty work that we do. And that we will do. I mean, that we enjoy. I'll show you exactly which part and how we are using it and all that. But if people come there with a lot of if but then, right? I mean, a lot of their attention initially just 4 days, and it will take 100% of their attention. That's why that was one of the factors. I was saying that you can do it as a preparation. Or some people, you know what, do pet projects, do something, and come to a point where you say, okay, the question about Scala, whether to use Scala is not in your mind. It's basically, okay, I want to learn. I mean, can someone help me bootstrap? And then you can come to us.
So one other question on the streams was basically, we have a case where we're basically reading data from a database, and it's a huge amount of data. And right now we're chunking it and basically sending it over. So I'm assuming streams would be a good case for use, where you could just stream things over. But what is the memory footprint when you are using it on, like let's say on a client side where you're streaming this, right? Are there explicit controls you get around how much you can chunk or you're sending record by record? Is there some kind of an implication of performance there?
Yeah. So the first thing is that even if you want to use it, ecosystems need to support it. For example, you may be talking to a JDBC driver or a NoSQL service. So your driver, now you can't write your own driver, right? Your driver has to give some ability to, either it should give you streaming API, or it should have some ability to be easily wrapped in a streaming API now, which I find a very challenging task. Right? I mean, if you have a JDBC driver, right, and if you have a huge data, then you have to have some lot of custom work needs to be done before, because at that interface level itself, you want to basically convert it into a stream. Some of the drivers, like we are using Mongo, and we are using a driver called Reactive Mongo. It gives us, we are not actually using a lot of streaming capabilities of our system, but it does at least give future-based API and non-blocking APIs. We don't have to do a lot of learning ourselves. So I think that is a prerequisite. Having said that, if you manage to do this kind of a streaming, right? What I see that web service clients, right? Web service clients are a great way to interface if that is feasible. For example, there could be a custom XML database. Right? Their drivers, of course, are blocking and will all the time will be blocking, but they will allow you a JSON over the wire, right? HTTP. Then Play client which or any RX Java client, right, for consuming your web service calls, that will be non-blocking, which means that the blocking stuff is happening on that product, right, on that server, but your application is completely shielded because your application is just using web service API, which is giving either futures or stream. So if you could convert your problem of direct connection via protocols to web service based connection, then your options suddenly open up. But now you have to see how efficient in terms of maybe the size and transfer that is, right? So that is one. And but once you get the stream going, I think it is not bad. You can't could not have used something like RX Java because they were actually building a server, right? They were actually saying that okay, now deploy on our server. And you said, well, there's a cache there because if you overwhelm the consumer, right, there will be memory leak. I mean, so they had found the safer option of iterating. But in your application, if you are getting an image or data from one place, I think you are much better off. What are the alternatives? The alternatives by hand or not doing that at all. So I think you should go for it. But your web service client
is basically if you're reading from a database, JDBC or whatever, inherently is a blocking call.
A blocking call,
right? So when you get data, yes. If I make that blocking call really small, then my overheads of basically hitting the database and doing those.
Possibly, I haven't actually spiked it. I haven't seen that. Okay, I don't care about a lot of threads.
I'm introducing an additional I/O operation, right? And that would become, I think, the bigger bottleneck at this point.
Yes.
So the advantage I get by streaming is readily lost because I've increased my I/O.
Actually, these things are so subtle that I think I would encourage that spike out. Spike out a little, see how it works, whether you can profile it and see. It might work. It might work. I mean, these are very small things. Maybe there will be some help, some API, some exhibition context which you will be able to arrange, and things will just work out. That's what I've seen that in custom situations, right? It's better to see whether it is working there.
So in your case, you're not using streaming.
Streaming we have not using a lot because for us, we did not want to rely on this custom bindings between Play and RX Java. And Play's inherent streaming APIs are very difficult. So they are really Haskell-like things, right? Very difficult. Hopefully in future when they have a similar APIs, we will make bigger use of that. There are also limitations. So Play's web service client, right? Even though it can get a post. While posting, it could not stream at least as far as I remember. While if you want to use a web service client and post it to a third-party service, there was no easy way to stream from your side. So anyway, I mean, just getting it from one end was not enough, right? So it has to be both, right? Reading as well as how I post. But all these problems are transient, and I'm sure. I mean, by the time someone tries it out, it will already be there.
I mean, at least a few places on the net they talk about streaming as they talk about reactive, but the things they talk a lot about streaming. And the thing that is hard for me to understand is that if I'm streaming, but inherently I have a blocking call somewhere.
Which is that's when which means that okay, if your application is one system A, right? Within that, if it is a blocking call, then it will not work. So you will create system B using an execution context basically, and on that you might work. But that may not also scale very well. So what I'm saying is that if you bypass that problem. So for example, if there is a Mongo gives a JSON API, right? I mean, Mongo driver is like all blocking, but you know what? There is a HTTP API for Mongo. And then I say, okay, well, I will use my Play client, which is all stream-based and all non-blocking, right? And I will get what I want. The only thing is that the load. I think we have managed to bring one data server down with our application. So you know what? It's very. You saw that you take a list of items. Hopefully, it will be finite and small. And then you know all the operations in parallel. So future operations are all happening in parallel, right? They are I/O operations. There is no CPU involved. So they just start basically, right? And then you say future.sequence, so you get a single result back, and we do this kind of style all the time. Now that is okay. I think we do not. Our objective, as long as our server is up and running, that is great. But then we are using a third-party system for storing our images, which could be served in the browser. So we take our images, and that whole system for uploading, publishing on that. So there is a CMS kind of a system in our API, as well as in their system. Right? We did not take care of that, and there got huge escalations later on, right? Saying that okay, we got a data center level issues. That was the email was sent to us. So what I'm saying is that if you use your tools, maybe you are covered, but the systems that you are interacting with, they are not covered, and they better scale or you better respect their SLAs. Or else, because the blocking is continuous. I mean, you get out of you, but it has to go somewhere, right? Something has to take that load. And if everything is reactive, great. Otherwise, there will be some problems somewhere. The reason for this initiative, if you see, right, all this company, Netflix, Red Hat, they are working together because they almost want to treat it like a end-to-end. I mean, it should not be just okay. I have got a reactive stream, I'm working, but you know what? Your APIs are blocking, and I will just keep you. No, I said that okay, all of these guys implement an API standard, and then there's an interoperability. But okay, I mean, some pivotal product or some Red Hat product, okay, they're offering me reactive streams on JVM till now. And then I'm able to consume it using time stack, or then pass it to Netflix or Java. That interoperability is required. It's almost like your protocol level capabilities, right? I mean, you can't say that okay, only this is a TCP network. Rest everything I don't care. Everything has to be that for the whole internet to scale. They're trying something similar. Once this establishes, things will be much more available. But I think you have to see in a particular case how.
The example that Ravi said, like in the case you said, like you will consume the data as JSON also or as a stream also. So in terms of performance, like sending the data as a stream or a JSON, which would so like I'm talking in terms of memory footprint. Maybe IO is.
So when I demoed this, stream and JSON, they're not exclusive. The chunks you could pass it as just bytes, or you could, if you, I think, it just show you one part of this, right? You will appreciate it. So if you could client JSON stream, this goes to line chunks. So it's like ultimately when I say this method, right? I'm getting a stream. Forget about my enumerator. It's just stream of array of bytes, right? And in my application, I make a choice that if I want to create into a chunks, line chunks, or a line stream, or maybe one of these will be used in some places to actually create a JSON. So who is passing it? I think this guy is being passed. Okay, so at some place I will convert from array of bytes, a stream of bytes to stream of strings to stream of JSON. They're just transformations. I mean, they're not exclusive. It's not that okay, either I'm using JSON or I'm using strings. Stream is just a mechanism of getting bytes or basically a part of your data. But that data could be, to begin with, it will be bytes. Then you transform it to string or something else.
So, if I understand correctly, like when I am dealing with streams, so the chunk of bytes that come with that the packets that would be pretty small.
It will be delimited by the sender. So sender can chunk it very small, or it can chunk it big. And then sender can say that okay, you know what, every chunk is a logical data item like a tweet. Or it says that okay, you know what, multiple chunks may form a single tweet, right? And all those things, which like depends on what kind of API.
But when I use JSON, so
that is your application. There is no JSON in streaming. Streaming is like okay, streaming data is over the wire, finally coming to you as bytes. You decide and read the documentation of how Twitter streams specifies that. You decide and you convert it to JSON if you wish. That is your application. It's not related to streaming at all. Cool. So anything else? This area, Scala, Play, streaming.
So I think you very well highlighted the difference between blocking and async, or rather async and non-blocking, the difference between the two. I think the subtle distinction between the two is, I think, very important.
I think this is my learning also, because when I started development and looking at this, it was very confusing. So I think this is my attempt to basically put some structure. I don't think that many people will agree with the terminology I have used here, but this is my way of arranging it, my mental model, right? Which helps. Cool then, should we?
thank you.